All right, chapter 10, we now start some of our statistics. So we're going to start off with how to design an experiment, and more importantly for elementary school students is how to collect the data and then interpret the data or data. Now there are going to be some definitions we need to go over, and then as we go through them, I'll go through similar type example as we carry it all the way through this section. So first of all, let's take a look at what we mean by data analysis or data analysis. Okay, data analysis is just an informal approach to statistics. And the statistics that we will be doing are going to be, excuse me, introductory level statistics. So a formal approach to statistics. Okay? So we're going to be collecting data from our students, and then we're going to learn various ways of analyzing data. So we're going to explore basic ideas by looking at a few areas. So we're going to explore basic ideas of statistics, and the first one we really want to work on is collecting data. Okay. Then we're going to talk later in this chapter about organizing data, and I'll refer to it today, but we'll get more specific practice starting next section. And then we're going to be finishing the chapter with interpreting or analyzing the data. Okay, analyzing or interpreting the data or the information. So oftentimes start thinking science fair. If you did a science fair project, one of the things you had to do in elementary school was collect whatever data you were going to do, organize it, and then analyze or interpret your results. Okay. All right, so let's take a look. We've got several definitions to look for first. Okay, so first of all, we want to take a look at different kinds of variability. So the definition of variability, and the root word kind of tells you it's going to vary, it's going to change. So it's the amount in which different elements or pieces of the data differ in the data set. The amount in which pieces or elements of data differ in a data set. Okay, and we have different types of variability. We have 4 different types. We have measurement variability, natural variability, induced variability, sampling variability. Okay, so let's do kind of some subsets of what kinds of variability we have. All right, so the first one we're going to take a look at is measurement variability. Now remember, variability means how much it could differ or change by. Measurement variability, when we take a measurement, is it guaranteed to be the same? That's our kind of our question, okay? So measurement variability. When taking a measurement, how far off? I have a little bit of room left. When taking a measurement, there is no guarantee of having the same outcome. Or the outcome will be the same. Right, so you're taking some sort of measurement. Okay, for example, let's say I'm trying to create a question, and you might say, now remember, we're looking at measurement. So maybe you say, well, how tall are you? If you ask every child in the classroom, if I asked every child, every student in my class, well, how tall are you? Are we guaranteed that we're going to get the same outcome? Well, the answer is no. It's going to be rare that we even find two people in class that are the same height. So that's what we mean by taking a measurement and having it vary. Okay? Now let's take a look at natural variability. So think about nature. Is everything in nature guaranteed to be the same? Okay? Is every similar item in nature guaranteed to be the same? And sometimes people go, well, yeah, all pine trees are exactly the same. Well, no, they actually have different makeup. With humans, let's say you have identical twins. Okay? Let's just think about identical twins. Are they identical in every single way? Well, the answer is no. They may look the same, but they each have their own set of fingerprints. They each have their own emotions, personality, aptitude. So identical twins may look the same, but they're not actually absolutely identical. All right? And of course, when we get down to characteristic traits, no two people are absolutely the same. All right. That's what we mean by natural. Now let's say we say induced variability. Oops, I've got the I. So let's think about the word induced. You're going to bring something on. Okay? So in an experiment, will each item or member react the same to a given event, to a given stimuli? In an experiment, will each, you can call them members, that'd be good. Will each member react the same to a given stimuli? Okay, so let's think of it this way. Right now, if I walk over to my thermostat in my house, it reads 72 degrees. Does everybody react the same when the temperature is 72 degrees? Well, no. Some of you would say, oh my gosh, that's way too warm. I'd be sweating. Others would say, oh no, that's perfect. That's perfect. Others would say, no, 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 that's way too cold. I like to be bundled up. I like my house to be 74 degrees. So an example of induced. So we're bringing it upon. All right, think of your classroom. If you had a 72-degree classroom, some people might find that too warm. Some might find it too cold. So does everyone react the same? Okay. Do all people react the same if the temperature in a room is 72 degrees Fahrenheit? And even within your own home, you may say, oh, some of you are like, oh, I sleep great when it's 64 to 68. Somebody else might say, no way, that's way too cold. I like it 70 to 72. So there's an example. Here's a good one. As future elementary school teachers, think elementary science fair project. Okay? Elementary, science fair project. One of the classic elementary school science fair project are the bean plants. And if I have a bunch of beans, I want to see if I induce something on them, are they all going to react the same? So in one cup, maybe I have a bean and I water it. I feed it water every day and it grows. But in another cup in the dirt with the bean, I put and only feed it soda. Will it grow the same? Another one, maybe you put coffee. Another one, maybe you put Kool-Aid, and you just see if all of them behave the same given a stimuli. And so that's what science fair is all about. It's trying to teach the students how inducing a variable onto your item, what is going to happen. So that's an important thing. And then the last one is what we call sampling variability. So I need a little more room over here. I'm going to put it right down here. Okay, sampling variability. So I will give you more of an example of sampling variability. Okay. If you sample a group of people, will your outcome always be the same? So when sampling, here I'm going to do it this way. Different groups, will the outcome be the same? So we're sampling. Okay, we're giving a sample. So let's say, for example, if I ask you a question to college students in California and I get your response, is that same response going to be the same to maybe a group of students in college that I sample in North Dakota? For example, I could ask you, here it is February, I could ask you, in California, in Bakersfield, California, we are in winter right now, it's February. So if I ask you, is it cold outside? Some people might go, well, yes, it is cold outside because it's 51 degrees. But if I ask the same question to college students in February, to a group in maybe North Dakota, and you say, is it cold outside? And they say, well, yes. Well, how come? Well, it's cold to them because it's 7 degrees outside. And you say, well, would you consider 51 degrees cold? A group in California might say, yes, 51 degrees is cold. A group of similar-minded people in North Dakota might say 51 degrees is not cold. 51 degrees is warm. 51 degrees, I walk around in shorts and a t-shirt. So sampling variability occurs when you give a question to different samples to see what the outcome is. So I'm just going to, here, I'll do this one. Ask college students in both California and North Dakota if 51 degrees Fahrenheit is cold for a weather forecast. We'll do it that way. And of course, it all depends on who you're sampling. okay? All depends on who you're sampling. So that's what we mean by variation or variability in sampling. So we've kind of talked a little bit about what kind of variability we can have. Now we want to spend some time collecting data. That's why I left this up here. So we're going to spend the rest of the time looking at data and kinds of questions, whether they're biased, not biased. So let's take a look at that. Then again, we'll spend next section looking at organizing your data. And I'll mention it, but I do have for the next section pre-typed up some examples that are already typed up so that you can walk through the lesson without having to copy down all the data points. Okay, well, let's take a look at some collecting data. Well, before we do, we need to talk about what we mean by a population. This is the total group or objects or people, okay, that are involved in the entire experiment. So it's the total group of objects or people involved in the experiment. So as a teacher, one of the easiest populations to use is your current classroom, or the school in which you are teaching, or the town in which you're teaching, or the city or the state. But it's just a controlled population, controlled group. And then we have what are called a sample. And a sample is a subset. It's a smaller group within the population. So you could say, okay, of the third grade classes at Independence Elementary, and then you might say, well, there's 4 third grade classes. So the population would be the third grade classes at Independence Elementary School. A sample might be, you know, Mr. Hill's class of third graders. So it's a subset of the entire population. Then we have what's called a simple random sample. Okay? It's a sample in which all the subsets are the same size. So if you're familiar with sports, for example, you might say, all right, well, if you've got all these Major League Baseball teams, okay, but each team can only have a 40-man roster that they travel with. So although you have a population of all the Major League teams with all the players, if you're talking about the roster that they can travel with, they all have to be the same number, so that would be considered a single random sample. All right? So that's what we mean by that. And so then what we want to do is, as a teacher, we've got to think about how to formulate the question. And oftentimes the teacher will come up with the original question, but depending on the grade, depending on if you are super young, kindergarten, first, second grade, versus a little bit older, maybe third, fourth, fifth grade, versus a little bit older, could be junior high or high school, the way you formulate a question and collect data is going to be different. So let me kind of work through examples of this. So let's say we're looking at early grades. Okay? So let's say we're looking at you're working, and this definition of early grades can change. So don't start thinking, oh, early grade only means K through third. That's not necessarily true. This is always going to slide depending on what we're talking about. You could say early grade is kindergarten, middle grade is first grade, and the upper grade is second grade if you are working with counting animals, okay? But you could also say, well, early grades are elementary school. Middle grades are 7th through 12th grade, and upper is a four-year university. Or you could say early grades are elementary education, K through 12. Middle grades are your undergraduate degree in college. And the upper grades is anybody working on a PhD program. So you can see where you can redefine what we mean by early, middle, and upper. Okay? With early grades, with the beginning step, you want to start with a simple random sample. All right? And I'm going to give you an example, so hold on. And more than likely, when you're working on experiments in elementary school or elementary, you provide the question for them. And I'm going to give you an example here in a minute. We'll kind of walk through it. And then if they move to like a middle grade, and again, we talked about that could be different depending on what we're referring to. Now, they may need to, and it's a good class project, they may need to, with guidance from their supervisor, in this case the teacher, they may need to develop their own questions to ask. Okay, so for example, well, we're going to do one here in a moment, but, and that's part of what the science fair project, again, sometimes for early years of science fair, I think it starts around second or third grade, oftentimes the teacher will provide a list of experiments that students can do. One of them included the beans that we talked about earlier. Maybe when they get a little older, they've got to come up with an idea. One of our children wanted to know if you took a rubber ball and you had the rubber ball at various temperatures, do they bounce the same height? Okay, but she came up with that idea on her own based on the fact that her, soccer, when the ball is cold, maybe it doesn't bounce as high. Baseball, tennis, okay, well, baseball shouldn't bounce much at all. But will the ball behave differently depending on temperature? Then upper grades may not be as specific as a ball bouncing. It might just be, does temperature affect the outcome of? So upper grades tend to make more generalizations. Once they realize the various biases that occur, outliers occur. So here we're making more generalizations. Or temperature affects ball performance. That's more generalization. Okay? Once the students recognize ideas concerning, I'm trying to think of what I said, various biases. Or outliers. They have a little more idea of other things that can involve or can affect an experiment. Okay. All right. And then before I give an example of these, let's take a look at what we mean by questions. We have fair versus biased questions. So let's take a look at that. Because when you go to set up an experiment for your students, when you go to read various experiments and the outcomes of experiments, we've got to find out if it's a fair or if it's already a biased question. So for a lot of times, students don't know what bias means, okay? Fair, let's start with a fair question. A fair question does not slant or sway an outcome. Fair questions do not slant or sway an outcome. Okay, whereas a biased question could potentially slant or sway an outcome. Now let's think about how this might work with an elementary school child's thinking. A fair question might be, what is your favorite ice cream flavor? Simple, direct, you don't make an expression, you just ask the question. A biased question could be, oh, last night, man, I had some chocolate chip ice cream, it was fabulous. And, you know, my husband had pistachio, which, well, I don't like nuts. And then you say, so what's your favorite kind of ice cream? Well, what's happened is you've sort of swayed the person. If they like peanut butter ice cream because it's got peanuts in it, but they've heard that you don't like anything with nuts in it, they might be less likely to answer, they might be less likely to answer that. Or another classic is just one word difference. Okay, now that if I hopefully this doesn't bother anybody, but it kind of gets the idea across. Have you kicked your dog lately? And you think, well, that's awful. It's either yes. No, let me rephrase. Have you kicked your dog? And then you go, no, or yes, whatever it is. But if I changed it, have you kicked a dog lately? Well, there's no way you can answer the question without sounding like you're beating up on your dog. So how you phrase and express a question can already imply bias, okay? And somebody else may have a better example, but it kind of, I think you get the idea that there's really no right way you can answer the question, or you have emotion which could impede the decision of whoever you're sampling, okay? So let's look at an example. All right, let's kind of walk through how we can take the same idea, but walk through same idea, but different levels depending on age and experience. So again, we're just looking at collecting. We'll do the others later. Okay. All right. So we'll sort of walk through, and the idea behind it is we're going to survey our class on pets in their household. And so what, depending on what we're talking about and what grade, will depend on how you ask the question. So here's our scenario. Okay. We're going to survey the population, and I'm going to be very, 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 very general on pets in your household. And I'm going to formulate the question differently. We're going to look at it differently based on their age and experience. So the first thing we want to do is we want to go, okay, let's, as a teacher, we need to form a question. Okay, so let's do this. All right, we're just going to go early, middle, and upper, or I'm going to call them elementary, That could be early. Now that could be elementary school, or that could be elementary grades like K through 2, K through 3. Then we're going to say middle. And again, middle could be the middle school, 6, 7, 8, 7, 8, 9. But it could also be the middle grades, like 3, 4, 5. And then we're going to do higher or upper. And of course, that could be high school. Remember, we already talked about how you can kind of slide the scale depending on what you need. Okay, so elementary school, you have a kindergartner, you have a first grader. One of the questions you might get is keep it simple. Keep it simple. So we might formulate a question like, how many pets are in your house or in your household? So think about what the responses could be. All right, so they're sitting there, and in my household right now, if I were to ask how many pets are in my household, I would say, well, we have 2 dogs and a cat, so I have a total of 3. Somebody else might say, well, I have 3 cats and fish. And then they usually ask you, do I have to count each fish individually, or can I just say fish? And that's a personal decision you can make. I usually just say category fish. Somebody else might say, well, let's see, I have a bird, and I have a turtle, and I have a dog, and we have a lizard, and we have a chicken, and they start listing. But notice, elementary, all they have to do is how many. They just have to come up with the total number of pets. Okay? For a middle grade, for something a little older, maybe 3rd, 4th, 5th, or again, middle school, you might say instead, what kind of pets do you have in your household? Are in your household. So now what we're going off of is, it's not just a number, but now, because you've got what kind of pets, they need to be able to infer the differences between dogs, cats, birds, fish, whereas the elementary, the littlest ones, are just looking for a total number. So they just walk around the house. They may not know what a ferret is called, but they know it's a pet. Or they may not know how to say iguana, but it's a pet. So they're just looking at a number. So middle, what kind of pet? And maybe a higher level type question for the same thing is, well, how many mammals, reptiles, birds? So we start categorizing. How many mammals, reptiles, birds, or none, etc., are in the household? So you can see what's happening is the level of understanding is being elevated as they're getting older, as they're higher up. And then I remember in biology learning something about, classify by kingdom, phylum, and all that. That could be also a higher level. So of course, remember, this is a sliding scale. Okay. So what's great is in an elementary classroom, you could work with your vertical alignment, and you could talk with your elementary school, kindergarten, first grade teachers and say, okay, we're gonna use this question in elementary kindergarten. And then maybe a 2nd, 3rd grade teacher says, okay, we're gonna start categorizing as to what kind of pets, because maybe we start learning about gerbils and guinea pigs and that there's other pets. And then the higher grades, well, now that they're learning the differences between what a mammal is, or, then they could take the same type question and keep developing it. All right? So once we have our question, now we've got to collect the data. So I'm going to do the same type of thing. I think we have this now. So the second thing we need to do is collect the data. And we're going to work specifically on these in the next section. Okay? So again, we're going to do the same idea. We're going to have elementary. We're going to have middle. And we're going to have upper or higher. I'll try to keep it the same. We might go, okay, now that you've asked your elementary how many pets are in your household, how are you going to organize that data? Well, you might do a table of values. Okay? So what do I mean by that? Well, perhaps you have a table, and in that table, you say, all right, I'm going to make a table. And I'm going to say number of pets in the household. I think I'm about to run out of room. Number of pets in household. And then going down, you might have student name, child's name. So you might go, okay, and you just survey going around the room. Child number 1, how many pets were in your household? Well, we have 3. Child number 2, how many pets are in your household? Oh, we have 1. Child 3, how many are in your household? We have 0, etc. So they're just making a table of values for the number of pets. Then you get to the middle grades and you want to collect it. But remember, our middle question was what kind of pets? So now we're still going to use a table. It's more of a frequency table because now I might still have whatever student we have, and I might still have child number 1. It could even be the same child. We just progress them through elementary school. But now what kind of pet do you have? Well, we have dog, we have cat, we have bird, and you have a list of all the potential pets that you decide you want to include. I have fish at the end. And, child number 1 fills in the chart that says, well, I have 1 dog, 2 cats, no birds, no fish. But child number 2 has, 2 dogs, no cats, 1 bird, and 20 fish or something. Okay? If you decide to count fish as an individual. And so you're making a table, but now that table has a little more detail to it. And then this upper or the higher, and remember we talked about how would you classify them. So the higher grade, they might go, well, I'm going to go to a stem and leaf plot. Or they're going to do a table, and maybe it's a double or triple bar graph. There's a lot of things that we're going to look at. So we've elevated because they're asking, they're asking a little bit more detailed information, but you could still do a table of values, mammals, reptiles, birds, etc. Okay. So now that we've formed the question, now that we have collected the data, we need to analyze the data. And again, this is where elementary school science fair projects are great for them going through the process. That's why it's so important for the child to do the project. Okay? As an adult, it wouldn't take you very long at all because we're more familiar, but it's important for them to go through that learning process. So the third thing we need to do is analyze our data. And I'm going to do the same thing. Elementary, middle, and upper or higher. And then this really changes as you get into higher education with modeling on a computer, things like that. But that's a little bit beyond what the scope of this class. So our idea is elementary school, K through 8. Well, with elementary, remember, was a number. How many pets in your household? So for elementary level, you're probably going to be using a table and maybe a single bar graph. And again, we're going to go through all of these in the next section. We're just sort of learning about them now. And you can always look ahead. Or middle level, we're probably also still using a frequency table, and maybe it's a double bar graph or triple bar graph. So I'm just going to say double, triple, maybe it's just a single bar graph. And then, as we said before, with the higher level, depending on the level of how high you're going, we could have a stem and leaf, frequency distribution. So I'll do this, a frequency distribution. You could have a table. You could have bar graphs. Of course, you can always use what you've learned in your past, but you might have a stem and leaf. Okay, and then eventually you might get into computer modeling. All right, now that we've got the data, we need to learn how to interpret the data. So what does interpret the data mean? Interpret the data is when you then provide the graphs, provide the charts, and you've got to then make a statement about what do you feel all of this represents. So, our fourth thing here is to interpret the data. Am I right here? Interpret your results. You can't finish an experiment without, at the very end, kind of coming up with what do you think happened? How do you think it means? So, here, let me kind of give you an idea. With our elementary, I'm going to sort of sum up what we've done. We had a question that said, how many pets are in the home? Or household. That was our question. Now I'm going to just make up some interpretation because we've already gone through this a little bit. So I might make a table. And that table is constructed by a column that says students and a column that says number of pets. You always have to label your, like here's my title, how many pets in the household? Here's my table. So let's say student number 1 had 5 total pets. Let's say student number 2 doesn't have any pets. And student number 3 has 2 pets. And of course you could keep going. You might say, okay, well, how are we going to interpret this data? Well, we mentioned that we'd have a table and a bar graph. So elementary, we would be teaching them how to make a bar graph. And we're going to go through this. I'm just going to kind of show you what a bar graph looks like. And we'll learn the proper way of constructing a bar graph. And you might say, all right, well, our output is, highest number is 5. So I might go 1, 2, 3, 4, 5. I'll go up here to 6. And always label, always. So you might have on this side is number of pets. And on this, across the horizontal axis, is a student. Child's name, something like that. So for student number 1, we have 5 pets. So if we have a bar, we come all the way up here to 5. And just to make it look a little bit neater. So we might say, okay, student number 1 has 5 pets. And we'll go through specifics on how to do that. Sometimes you'll see a little dot up here because it's kind of like going up to the number 5. Student number 2 had 0 pets. So you might just see a bar that's right there at 0, or sometimes you just see one data point. Student number 3 had 2 pets. So I'm going to come up here to 2 and make a bar that is too high. So sometimes they write it on there, sometimes they put a data point. And that bar graph would represent, oh, I'm so sorry. Let me move this last one over because I didn't realize it was off the screen. Student number 3 goes to 2. Now is it there? Yep, it's a little bit, apologize about that. You can put the number on top to say how high it goes. But the idea is the student learns to look, oh, the higher the bar, the bigger the number. Now, middle, oh, let's interpret. Okay, so your interpretation, what would the child be learning? would you ask your kindergartner, your first grader? Well, basically the idea is, can they understand what the graph represents? Can the students understand what the bar graph represents? And we just already talked about it. Hopefully they start recognizing, oh, the higher the bar graph is, the bigger the number. That starts eventually leading us into graphing and just understanding that the difference in greater versus less. Now, middle, remember, we said what kind of pet, not just how many, so what kind of pet. So same idea. What kind of pet? Are in the house. Excuse me. And we said, well, we're going to make a table of values, but this time student number 1 can have various inputs. So if I make my table, I'm going to move it over here so I have a little more room. I apologize for that. I might go, all right, I have student number 1, but we have dogs, cats, fish, birds, I don't know, turtles, whatever you have. And you have a variety of students. So I have this table. And in this table, we said, okay, here's our student. And then across the top is we have dog, cat, fish, I don't remember what all we said, bird, turtle, other. You could put an other category. And then you have student number 1, number 2, number 3, and you collect the data from all your students in your class. Okay? So we're just going to make this up. I'm going to say student number 1 has 1 dog, 2 cats, no fish, no birds, no turtles. Student number 2 has 2 dogs, no cats, 1 fish, 4 birds, and 1 turtle. Student number 3 has only 20 fish. Oh, I'm going to give him a turtle too. Okay, 20 fish and 3 turtle, because the turtle needs something to eat. Now let's make a bar graph. But we're going to have a double or a triple bar graph. And I'll do a little bit of this, and I think we'll get the idea. So we might do the following. All right, I can color code it, but we can also texture code. So if I do my bar graph, and my title would be what kind of pets are in the household or pets in household, and I might say, okay, down here represents person or child number 1. I think I may only have room for 2 of them. I think you'll get the idea for the 3rd one. And on the side, so here's student. And on the side, we have number of pets. We always have to label your graph. So we have a title of it, and we have what our axes are. And then, since I have a lot of colors, I'm going to do colors. I'm going to say, okay, dogs, I'm going to make a little legend. Dogs, I'm going to use for pink. Cats, I'm going to use this pretty blue. And I'm going to color code. Fish, I'll do green. But let's say I don't have colors, then I can use a texture. Birds, I'm going to put as dots. And turtle, I'm going to do as cross hashes. So it's not important. You may have a colorblind student, so maybe you can't do colors. And then what we would do is we have number of pets. Now I didn't think this through when I put 20 down, because I would probably in elementary school go 0 through 20. So I'm going to probably run off the page here, but I might go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, So you can see that if I kept going, I apologize, we're going to run into the other words. I'm going to call this up here 20. And then we start making bars. Student number 1 has 1 dog. So student number 1 has 1 dog. So I'm going to put my pink one for the dog. 2 cats. So right next to it, it's going to be attached to that bar, and it's going to go up to the number 2. No fish, no birds, no turtles. So now I'm going to go to student number 2. Student number 2 has 2 dogs. Well, that's pink. So I'll go up here to the number 2. No cat, 1 fish. Well, fish is green, so I'm going to go here to 1 fish. 4 birds. Birds are polka dots, so birds are 4. I'm going to keep going all the way up here to the number 4. Dot, 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 dot. And 1 turtle. And turtle was little tiny hash marks. So I'm going to go hash, hash. So each of those bars has a different texture, and that's just a multiple bar graph. And then you've got the idea. Student number 3 has 20 fish. So now if I have student number 3, I'm going to go all the way up here to 20. Whee! Okay. And they have 3 turtles. 1, 2, 3. Come right off of this. Turtles were hash marks because I left a legend letting them know what each one was. And you could have done a legend off to the side like you all see in papers, right? So basically what we're trying to show is same type of question, but it's elevated based on age, experience, etc. So section 1 deals with the overall view of an experiment and how to collect data. The rest of the chapter will go through the interpretation, and we'll go through how to analyze it. All right? So until I see you next time, and again, I highly recommend for the next lesson, 10.2, print out the examples so that we don't have to write down all the data points, and you can just fill your notes in off of that, and we'll talk about that later. So hopefully this helps. Have a great day, and I'll see you next time.